Good day, welcome to this video where we'll be unpacking the quotient rule. Okay, we're going to start with a definition. Now I'm going to offer two examples, one in which I show how to directly apply the rule, and the second one I'll be extending it to finding equations of tangents to a given curve. Alright, so let's go for it. By definition, if f and g are differentiable functions, then the derivative of the quotient f of x over g of x is given by g of x times the derivative of f minus f of x times the derivative of g over g of x squared. So that is by definition the quotient rule. Okay, notice here we have a minus instead of a plus. Remember, plus works with the product rule and minus works with the quotient rule. Similar to how exponential laws works, right? When you multiply parts of the same base, a product goes with addition, and when you divide parts of the same base, then the quotient will go with the subtraction. Okay, so just a similar logic there, but this is the definition. And now let's go to the two examples that I spoke about earlier on. Okay, let's go for it. Right, so this is the example. We're asked to find dy over dx for this function y is equal to x squared plus x over 4 plus x cubed. Right, so our f is given there and our g is given there. So we're going to directly apply the rule itself to find dy over dx. So we go 4 plus x cubed times the derivative of our numerator, right, which will be 2x plus 1 minus, keep our numerator, x squared plus x times the derivative now of our denominator will just be 3x squared over what? The square of our denominator, 4 plus x cubed to the power of 2. Right? Again, no need to clean up. It's fine to leave your answer like this. Okay, so always double check your expressions, because whenever you have many terms, there's always a margin to make an error in your working out. So just double check that all the derivatives are correct and you didn't make sign errors as well. Okay, so this takes care of this question, and we're going to go into example 2 now, or question 2, where we're going to talk about tangents. Okay, let's go for it. All right, so this is example 2. Find the equation of the tangent to the curve y is equal to e to the x over 1 plus x squared at the point 1 is to e over 2. Right? Now, this is of course a quotient rule question, because we see division of fractions, right? And we definitely need to work with the quotient rule here to find the derivative. So let's start with that. Dy over dx will be equal to 1 plus x squared times the derivative of e to the x is e to the x minus e to the x times the derivative of our denominator 2x over 1 plus x squared, you square the denominator as well. Okay, let us clean up and see if we can simplify. Well, e to the x is our highest common factor here. We can definitely take it out. E to the x, we are left with 1 plus x squared, right, minus 2x over 1 plus x squared squared. Right. Now, if we rearrange the terms here, this looks like the square of a binomial, right? X squared minus 2x plus 1, that would be x minus 1 all squared. Okay, so e to the x x minus 1 all square over 1 plus x squared. All right, good. So that is as far as we want to take it. Where are we evaluating the derivative at this point? All right, so the derivative dy over dx evaluated at x equal to 1. If we sum in 1 here, 1 minus 1 is 0. So that will be 0. Because, yeah, we won't be dividing by 0, that's fine. So the derivative here will be 0. This tells us that the tangent line is horizontal. At the point of contact. Okay, that point of contact. Okay, so it's a horizontal line. You don't have to sketch this curve, but this is what we deduce and know and understand by getting a gradient of 0 with respect to the tangent line. Okay, so what do we need now? We use this equation, y minus e over 2 is equal to 0, x minus 1, so therefore the equation of the tangent line, which is just y equal to e over 2. Okay, so this takes care of example 2. Believe it was valuable. If you need to, you can rewatch this video to ensure that you have a clear understanding as to how to approach questions based on tangents, whether they are in the quotient rule or the product rule, and we can effectively work with that. Okay, I wish you well in your mathematics. Thank you for watching. I'll see you in the next set of videos.